So when we solve a linear system in 3 variables, what we have are 3 planes. Not airplanes, but imagine you had a piece of paper, then you had another piece of paper, and they intersected right there. And then you had another piece of paper, and it intersects. They all meet at one spot. So if you see the identity here, then this is your x coordinate, this is your y coordinate, and this is your z coordinate. So number 2 is pretty easy. Number 3 is a little bit harder. If you see if you see this, if you see this on bottom, that means that 2 of the planes are parallel, or more, maybe 3. So there's no solution. It's like saying, where do the floor and the ceiling and the front wall all meet? They don't. So that would be no solution. Okay. But what if the bottom row was all zeros? That means you have an infinite number of solutions. So imagine you had a plane. So if you're looking at the top and you had 3 planes that intersect like this, so it would kind of look like, I'm not going to be very good at drawing this. Nope, that's not what I meant to do. So and then those 3 planes intersect along a line. So there are an infinite number of solutions. Any solution in this center column or along this line is going to be a solution. So how does it want you to do this? Now, I mess this up sometimes. So when I mess it up, just forgive me. So what we have is one line saying infinite solutions, and then we have another line that says x plus z equals 0, and y minus 3z equals 0. Okay? And this is dependent. So independent means there's one solution. Inconsistent means there's no solution. And dependent means there are an infinite number of solutions, and those solutions are found inside here. So we need to solve for one of the variables. But I better actually find one. Otherwise, we won't know if I made a mistake. All right, so 5 practice. Let's do this. Dang it. Oh, shoot. I wonder if it'll let me in the... So we're going to steal one from Tembry. So the top row is 1, 0, 10, 2. And then 0, 1. And then all zeros. And then let me, hold on a second. Oh, let's give up. Okay, perfect. All right. So what this is saying is infinite solutions. That's what all zeros means. We also know that 1x plus 10z equals 2, and 1y minus 7z equals 5. So So it's going to ask down at the bottom, if the system is dependent, define the variable z as the free variable and write the values for the x, y, and z coordinates in terms of the z in the appropriate boxes. So we have to answer these three questions. Okay. Well, it told us that z is equal to z. Right? That's what the instruction said. So define this equation as z. And then what is x in terms of z? So if I take the equation with an x in it and I solve it for x, I'm going to get 2 minus 10z. And then I take the y equation and I solve for y, and I get 5 plus 7z. So what does this mean? Well, it tells us, so if I have those weird intersecting planes, so this one, and this one, and this one. So these equations here tell me where the intersection is. And it's kind of hard to think in 3 dimensions, but so this instruction tells you if you pick a z value, then what is the x value that corresponds to that? So this point right here, if z equals, say, let's do something easy like 1. If z equals 1, then where is the intersection? So we put 1 in for z, and then we plug 1 in there. 5 plus 7 is 12, so y is 12. And then we plug 1 in there. 2 minus 10 is negative 8. So that point lies on that line. Okay? And then we could plug in 2. So we would put a 2 here, and then we would get new values. Now it is possible to have one plane and then have another plane that's exactly over the top of it, and then a third plane. So there's the intersection right there. But those equations are instructions on how to find intersection points. You choose a z, and that z value will pick an x and a y, and that will tell you one of the intersection points in 3 space. So we're going left and right, up and down, and we're also moving front to back. As long as the instructions say define the variable z as the free variable, then yes. If it said define the variable y as the free variable, then your equations would be a little bit different. You would have a y here and and a y there anyway. So whatever it says is the free variable, then you just define it like this. So those aren't bad. Okay, so z equals z, and then solve the other 2 equations for z. Okay, thanks. You can have this back. Okay. All right. 4 is in the other video. 5 is in the other video. Do you need help with this one? So you're just going to solve for x or y. Yeah, I'll do it. So in this case, I have 2 x's and a single y. So let's replace that y with an x. You could do it either way, but it's going to be a little bit easier to replace that y with an x. So we add y, and we get x equals y. So I'm going to replace this y with an x. So negative 3x plus 2x squared minus 4x, and then I'm going to bring the 4 over and set it equal to 0. What? Now I have a quadratic. 2x squared minus 7x minus 4 is equal to 0. So I factor 2x squared and negative 4, multiply those together, we get negative 8x squared. Are there factors of negative 8 that add to be negative 7? Negative 8x and x. So we get 2x, x minus 4, and x plus 1. So our x values are 4 and negative 1/2. Does everybody understand that? Now I can plug those in here if I would like and solve for y, but that's going to be a mess. I have another equation that says x is equal to y. So if I plug 4 in there, then I get a 4 here. If I plug a negative 1/2 in there, then I get a negative 1/2. So what we're looking at is a parabola, and it touches at negative 1/2, and then at 4, 4. Parabola and a line. Now, is it possible for these to touch only once? Yeah. It could happen that you have a single intersection. Is it possible to have no intersection? Yes. How would you know if you had no intersection? If you ended up with a quadratic that doesn't factor and you plug it into the quadratic formula and you get i's. So if this doesn't work, then you need to use the quadratic formula. If the quadratic formula generates an I, that means that the two graphs do not meet. Okay. All right, so here we have two circles. How many times can two circles intersect? Well, none, in which case you end up with i's, or 1, or 2. Can they intersect more than 2 times? I guess they could intersect everywhere if they were the exact same equation. But those are your options, 0, 1, 2, or infinity. Okay. So how are we going to do this? Well, substitution is a mess. So let's solve this for x. So x squared equals 13 minus y squared, and then we take the square root. So we get x equals plus or minus the square root of 13 minus y squared. Now you can plug that in if you want, and it will work. But I would rather use elimination. So x squared plus y squared plus equals 13. Are there variables we can eliminate? Can I eliminate the y's? No. I cannot eliminate the y's. I have a y squared in both equations, but one of them has a 6y. But I can eliminate the x's. So I will times the bottom one by negative 1. And then the x squareds go away, the y squareds go away, and I get 6y equals 12. I think it's positive. Well, depends on which way you do it. So we get y equals 2. How many solutions does this have? I don't really know yet. I know that y is 2. So which equation do I want to plug the 2 into? It doesn't matter. The top one's probably easier. So we stick a 2 in here, and I get x squared equals 4. Nope. X squared plus 4 equals 13. Subtract the 4, and we get x squared equals 9. And then we take the square root, and I get x is equal to plus or minus 3. So what are the solutions? 3, 2 and negative 3, 2. When I plugged in the y value of 2, I ended up with 2 x values, which means there are 2 intersection points. 3, 2 and negative 3, 2. Were there any others you needed? This one's easy. That one's easy. And let's do a reminder here. So we have to remember x cannot be 2 or negative 2. So this is x minus 2 times x plus 2. So I need a common denominator. The left side needs x plus 2. The middle doesn't need anything, but the right side needs both of them. So x squared minus 4. Now I can delete the denominators. And I get 5x squared plus 10x plus 5. And then over here I have 4x squared minus 4, so I'll subtract those. So negative 4x squared plus 16 equals 0. And that gives me x squared plus 10x plus 21. So we get x plus 7 and x plus 3, which means x is equal to negative 7 and negative 3. Are either of those forbidden? No. We're not allowed to use 2 or negative 2. Those are not in the excluded list, so the answers are negative 7 and negative 3. What if a number is in the excluded list? And then you just chuck it. So the solution set, these brackets just mean a list of numbers. So it would be negative 7, negative 3. Yeah, so no, you don't have to do anything else. Okay, that's it.